Going to look at gas laws. Gas laws. So, the gas laws we are going to talk about today is the Boyle's law. In gas laws, we have so many laws. We have Boyle's law, we have Charles' law, we have Gay-Lussac's law, we have Dalton's law of partial pressure, we have Graham's law of diffusion, and probably Avogadro's law. But today we are going to look at the Boyle's law. The Boyle's law. Robert Boyle put up a law that talks about the relationship between the volume of a gas and the pressure of the gas. Now, Boyle's law states that the volume of a fixed mass of a gas is inversely proportional to the pressure at constant temperature. The volume of a fixed mass of a gas is inversely proportional to the pressure of that gas at constant temperature. So what he's trying to say is that when you increase the volume, when the volume of a gas is increased, it tends to occupy a larger space, and of course the gas molecules will keep moving and colliding, but the pressure they will be producing, the force they will be exerting in that container will decrease, it will go down. But when the volume is decreased, the space occupied by the gas molecules will decrease, and then the pressure or the force being exerted by the gas molecules in the container will increase. And that is to say that as the volume is increasing, the pressure will be decreasing, and as the pressure increases, volume decreases. So mathematically, Boyle's law is represented with this: volume is inversely proportional to pressure at constant temperature. So we introduce this, we remove the sign of proportionality and we introduce equality sign, and then our constant. So we have that volume is equal to the constant divided by pressure. So when we want to separate the constant from the volume and the pressure, we have that PV equal to constant. So Boyle's law is saying that P1 V1 equal to P2 V2, and if we have to extend it, Pn Vn. So the initial, if a gas is at an initial volume of V1 and initial pressure at P1, when the volume is changed to a new volume V2, the pressure will also change to a new pressure P2. Now let's take the graph. Let's look at the graph that represents this expression. The graph that represents this expression of the gas of of Boyle's law. Let's have a graph representing Boyle's law. Now here I have about 3 graphs. 3 graphs representing Boyle's law. The first graph is the graph showing the pressure, which is usually measured either in millimeter mercury or in Newton per meter squared. Pressure, and then we have volume here. Volume is measured in meter cube. Then we have the origin. If we are drawing a graph of pressure against volume, we'll have this kind of curve. What does it mean? As the pressure is increasing, the volume is decreasing, vice versa. We can also have this graph this way. Where we have pressure plotted against the inverse of the volume. The inverse of the volume, or 1 over V. The inverse of the volume. We are going to have a straight line from the origin. A straight line from the origin. We also have another graph where we can plot a graph of the volume against the inverse of the pressure. We'll also have a straight line graph, a straight line from the origin, telling you that the volume is inversely proportional to the pressure. Volume inversely proportional to the pressure. But when we have the pressure being plotted against the volume, not the inverse of the volume, we have a curve like this. Now let's take a problem. Let's take a problem. A gas occupies a volume of 250 cm3 at 580 millimeter mercury. Find the pressure if the volume of the gas is changed to 150 cm3 at constant temperature. So here we have been given the V1, the initial volume, at a particular pressure, the initial pressure. So we're asked to find the new pressure, or P2, at a new volume, the V2. So we take the equation P1 V1 is equal to P2 V2. Since we are looking for P2, we make P2 the subject of the formula. P2 is equal to P1 V1 over V2. Don't forget to substitute according to the variable you have here. So we have, what is our P1? Our P1 is 580 millimeter mercury times our V1, which is 250, divided by our V2, which is 150. So what do we have as our new pressure? We have 966.7 millimeter mercury. 966.7 millimeter mercury. Remember that as we have P1 here, you substitute the value of P1 here, and as we have V1 here, you substitute the value of V1 here. Remember to substitute correctly so that you have no problem.